Okay, so let's continue with our circuit. Now let's program it. Okay, so we'll be using a for cycle in order to light up these LEDs in order to go forward and then backwards, and we're gonna put that in a loop. Okay, so these LEDs are gonna go lighting up like that, and then going back, and then going forward, and then going back. So it's gonna look pretty neat. Okay, so let's go ahead and start coding. Okay, so first thing that we need to do is to define what pins we're gonna be using. So as you can see, we're using pins number 13, 12, 10, 11, and 9. So we need to define all of those pins as outputs. So here in the setup, we define pin number 12 as output, pin number 11 as output, uh, pin number 10 as output, and finally pin number 9 as output. Okay, so now we have defined pins number 13, 12, 10, 11, and 9 as outputs. So now let's go into our loop. Okay. Oh, one thing that I forgot. Well, let's get to that. We'll get to that in a minute. Um, so here in the loop, we want to run a code that lights these LEDs in this direction and then lights them back in this direction. Uh, and we want the program to do that thing infinitely. So we want to do that thing within the loop. So therefore, we write here inside the loop, we write what we want the Arduino to do. So we could do this with a simple with simple code like establishing digital write pin number 13 high, then delaying it, then turning it off, then delaying it, and then doing that for pin number 12. And we could do like a super large code for that. So let me start doing that. Uh, you'll see how we can make this thing quicker. So here we're turning pin number 13 on and we're delaying it some time. So let me establish how much time we're going to delay these things. So I'm going to create, you know what, let me put this higher. Okay. So I'm going to create, let's say, a variable called delay. Let's call it dt. And this thing is going to be equal to 50 milliseconds, okay, or 50. So right now, instead of writing down delay 50 milliseconds, let's call it 500. Okay, so instead of delaying 500 milliseconds and writing 500 down here, I can just simply say delay dt. So here, delay dt. So what this code right now is doing, it's turning on pin number 13, waiting 500 milliseconds, then turning off pin number 13 and waiting 500 milliseconds. So in order for me to turn 13, 12, 11, 10, and 9 and then forward, you would originally want to think to do this digital, right? I turned 13 on, then I turned it off, then I turned 12 on, and then I turn it off, and then I wait. So we could do this, and we could be turning on and off these ones individually, each and every single one of these guys individually, but that will take us too much time to write. So what we can do is we can put this inside another loop. Okay, so this in this lesson I'll introduce you to the for loop. So for in Spanish you would translate this to para. Okay, so for loop has three different you have to write it in three different syntaxes. Sorry, that's wrong. You have to write three different commands within the for loop. Okay, so for, and let's introduce a counter. Our counter is going to be called I. Okay, remember counters are normally called I. So for I equals to 13, comma, semicolon, I is what would be less than, no, greater than, sorry, greater than or equal to 9 I, oh, semicolon, I minus minus. Close this and open this thing up like that and close it here. Since I'm using this variable I that I haven't defined, I have to define it up here, int I. I'm gonna set it to 0 right now. So what's going on here? What's going on here in this for loop? It's I'm gonna say it in Spanish so that you guys understand, and I'm gonna repeat it in English. Okay, so para el valor de I igual a 13, o sea, empezando en I igual a 13, para que empezando en I igual a 13 y I sea mayor o igual a 9, vas a ir restando 1 en I. O sea, empezamos en I igual a 13. Este es el empiezo. Aquí es donde va a empezar el ciclo, con este valor. El ciclo va a terminar, bueno, va a durar mientras I sea mayor o igual a 9. Y cada vez que acabo un ciclo, I se va a restar 1. Okay, so these are the three different concepts that work here in the for loop. Okay, I'm going to explain it in English. So, for loop has three different conditions. The first condition is it's going to define at what value our counter is going to start. So right here I'm starting my counter in 13. The next concept is until when my loop is going to continue, like what is my condition for my loop to continue. So while I is greater than or equal to 9, so if this condition is met, we're going to continue doing our loop. And every single time that we finish our loop, I'm going to subtract 1 from I. So now it's just a simple matter of let's erase this right here like that. So now I'm going to say within this loop, I'm going to write digital write. Instead of writing pin number 13, I am going to put I right here. Delay, and then I'm going to turn the I pin off. So what is happening here? I'm establishing that the value of I is equal to 13. I'm going to repeat this loop as long as I is greater than or equal to 9, and each time this loop is finished, I'm going to subtract 1 from I. So let's go into here. So digital write I. So since I started with I value 13, what I'm doing is I'm writing, instead of I being here, I has a value of 13. So this would be equivalent to saying digital write 13, comma high. Then I'm going to delay 500 milliseconds, and then I'm going to digitally write I, which has a value of 13, to low. And then I'm going to delay 500 milliseconds. So now I completed this loop one time. I'm going to subtract 1 from I. So I now it's not 13, now it's 12. So I go here, I check if 12 is still greater than or equal to 9. Yes, so I go back into here. So now I say digital write, now it's pin number 12. I set it to high, and then I delay. Then I digitally write pin number 12, I set it to low, and then I delay. And since I finished already another loop, I is going to be subtracted by 1. So now it's not 12, now it's 11. So now we go back into here, we check 11, it's still greater than or equal to 9, so let's do the loop again. Digital write, now it's going to be pin 11, set it to high, delay, pin 11, set it to low, and since we finished another loop, I is going to be subtracted by 1, so now I has a value of 10. Go back here, check 10 is greater or equal to 9, yes. So I go here, digital write, pin number 10, high, delay, pin number 10, set it to low. I completed my cycle once again, so I subtract 1 from I, so now it's not worth 10, now it's worth 9. Go back here, 9 is greater than or equal to 9, yes, so I go into my loop again, So I set this to high. So pin number 9 to high, delay, pin number 9 to low, delay, subtract 1. So now I has a value of 8. I go back here, check. Is 8 greater than or equal to 9? No. Since it's not greater or equal to 9, I simply exit my loop and continue with the code here. Okay? So as I finished my code here, this what it's going to be doing, let's upload it. Okay? So what it's doing, it's turning on my LEDs starting from pin number 13, 12, 11, 10, and 9. And that finishes one loop, so it goes back again and does it all over again. So how do I turn them on going from here backwards? Well, I do the exact same thing again, but now I create another for loop. So let me stop simulation. Create another for loop, but this time, I'll go backwards. So I'll start from I equals to 9, okay, semicolon. I'll do this while I is less than or equal to 13 because I'm going to stop at pin number 13. And now each time this mini loop finishes, I'm going to be adding 1 to I. So instead of putting minus minus, I'm going to put plus plus. And I'm going to open my semicolon, no, my curly brace, close my curly brace, and put my code here, which will be exactly the same code as here. Okay, so what I'm doing now in this second part, I'm starting with I equal to 9, while I is less than or equal to 13, I'm going to add one number to I. So let's start here. We finished our code here, and we start in this second loop. I'm going to start with a value of I equal to 9. I'm going to do this while I is less than or equal to 13, and each time this loop finishes, I'm going to add 1 to the value of I. So I go here, digital write I. Originally, my I is worth 9, so I'm going to digitally write pin number 9, set it to high, delay. Pin number 9, set it to low, delay. And since I've already finished this loop, I will add one number to I, so now it's worth 10. I go here. 10 is less than or equal to 13, yes, so I'll go back in here, set 10 to high, then set 10 to low. We finish the loop, we have to add 1. Go to 11, 11 is less than or equal to 13, 11, 11, and so on and so forth. So what this thing is going to do, let's upload and run this thing. Whoops, what's going on? Oh, I'm missing this was a semicolon here. Upload and run. Okay, we're done. So it goes here, then turns this one on, and goes backward. Bup, 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 bup. So what I can do now is if I want to make these things light up faster, I can set my delay in between these things to a smaller number. So that is the importance of using a value here and establishing the value here instead of writing 500, 500, 500, 500, because if you want to tinker with this number, you can just simply modify it here at the top, and then it will be used here and the rest. So look what's going on. Whoop, 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 whoop. Now it's running faster. Okay, look at it. Look at it. Pretty cool, right? Pretty cool. Pretty cool. So that is basically it. That is basically it for this code. And you guys should have enough tools in order for us to start actually programming our final project. Okay, so what I'll do in the next video is I'm going to show you, and this is going to be it's going to help you a lot with your how do you call this with your project. I'm gonna do this code, but starting with make it start with a push of a button. So stay tuned for the next video. Thank you guys so much, and I'll see you on the next video.